So we have to find out the sum of the following series up to n terms and up to infinity. Okay. So over here we can see that 4 minus 1 is 3, 7 minus 4 is 3, 10 minus 7 is 3. So basically the terms in the denominator are increasing in the form of AP. So of that AP, let the nth term be. The first term is A. We know the formula for the n term of an AP, right? That is A plus n minus 1 into D. So this will be 1 plus n minus 1 and the common difference is 3. So we have 3n minus 2. Alright, so writing the nth term of this series, Tn, so this will be equal to 1 upon, so over here we have 1, then 7, 1, then 4, then 7. So the first term has to be 3n minus 2, and to that we are adding 3. So that is 3n plus 1 and plus 3, 3n plus 4. Okay. So this will be our Tn and we have to find out the sum of this Tn. Now, in such series, the general way of solving this is we have to multiply and divide by the last minus the first term, that is 3n plus 4 minus 3n minus 2 is equal to 6. So multiply and divide by 6. So we get 1 upon 6, and in the numerator, write the numerator in the form 3n plus 4 minus 3n minus 2. So here we are supposed to have 6, so 3n will get cancelled. 4 minus minus 2 is plus 6. So okay, and in the denominator we have 3n minus 2, 3n plus 1, 3n plus 4. Okay. So now just for this term, this and this will cancel out, and for this term, this and this will cancel out. So write the terms in that form. And we have 1 upon 3n minus 2 into 3n plus 1 minus we have 1 upon 3n plus 1, 3n plus 4. Alright, so let's just start substituting the values. So for T1, we have 1 by 6 into 1 upon, it will be 1 into 4 minus 1 upon, we have 4 into 7, 3 plus 4 is 7. Then for T2, we have 1 by 6, 1 upon 4 into 7 minus 1 upon 7 into 10. Then for T3, we have 1 by 6, 1 upon 7 into 10 minus 1 upon, it will be 10 into 13, and this will go on till for Tn, we have 1 upon 6, and Tn will be the same as this, right? So that is 1 upon 3n minus 2, 3n plus 1 minus we have 1 upon 3n plus 1 into 3n plus 4. Okay, so we can clearly see over here that the alternate terms are getting cancelled. So this will get cancelled, this will get cancelled. So we are just left with the first term and the last term. So let's just write that. So we have Tn as 1 upon 6, and the first term is 1 upon 1 into 4, minus we have the last term as 1 upon 3n plus 1 into 3n plus 4. Okay, so if we have to calculate the sum up to n terms, then this is our final answer. And if we have to calculate the sum to infinity, so this will become 1 upon infinity, so that is 0, and we are left with just these two terms, so that will become 1 upon 6 into 1 upon 4, so that is 24. So the answer is 1 upon 24. Okay, so the next series is summation of r plus 1, r plus 2, r plus 3, so that is tr. So let's just write tr is equal to r plus 1, r plus 2 and r plus 3. Now the term coming after this will be r plus 4, and the term coming before this will be r minus 1. So let's just multiply the whole thing by r plus 4 minus r minus 1, so that is r will get cancelled, 4 minus minus 1, so that is 5. So divide the whole thing by 5. So this will result in, now we have r plus 1, r plus 2, r plus 3 into r plus 4, the whole thing divided by 5, and then we have minus, now this will become r minus 1, r plus 1, r plus 2, r plus 3. The whole thing divided by 5 again. So now if you carefully observe these two terms, this is the nth term, right? Now over here, if you replace r by r plus 1, we will get, this will become r, this will become r plus 1, this will be r plus 2 and so on, and this will be r plus 4. So basically when we replace r by r plus 1, we get this term. So this term and this term will cancel each other out. So eventually we are left with just the first term of the series and the last term of the series. So let's write sum. The first term of the series Sn, the last term of the series, that will be n into n plus 1, n plus 2, n plus 3, n plus 4, the whole divided by 5, and then next we have minus, so r is equal to 1, so r minus 1 is 0, so this whole second term will become 0. So this is our required answer for n terms, and we have to find out the sum to infinity as well. So for infinity it is infinity, then infinity plus 1, so obviously the sum for infinity will be Sn is equal to infinite. Okay, so this is the rth term of the series, and we can write that as 1 upon, so that becomes 2r plus 1 into 2r minus 1. Okay, and then in the numerator we can just write 2r plus 1 minus 2r minus 1 upon 2r plus 1 into 2r minus 1. So in the numerator we have 2r will get cancelled, 1 minus minus 1, so that's plus 2. So divided by 2, so that the whole value remains constant. And then this can further be simplified into, we have 1 upon 2r minus 1 minus 1 upon 2r plus 1. Okay, now if you observe this series, replace r by r plus 1 over here, and we will get 1 upon 2r plus 1. So basically all the terms in between will cancel each other out, and we are left with just the first and the last term. So our final answer will be 1 by 2. The first term is 1 upon 1 because r starts from 1, so that is 1 upon 2 minus 1, so 1 upon 1, minus the last term will be 1 upon, it will become 2n plus 1. Okay, so for n terms this is the sum, and if you have to calculate till infinity, then this will become 1 upon infinity, so that is 0. So our final answer in that case will be just 1 by 2. Okay, so in this sum we have in the numerator positive odd numbers, so that's 1, and then 1 into 3, then 1 into 3 into 5, and in the denominator we have even numbers but starting from 4. So to make the series start from 2, let's just multiply and divide by 2. So that would become, so this is 2 into, it would be 1 upon 2 into 4 plus 1 into 3 upon 2 into 4 into 6, then 1, 3, 5 upon 2, 4, 6, 8, and so on, and up to n terms. So the nth term will be, this is 1, 3, 5, and the nth odd number is 2n minus 1 upon, we will have, so that is 2, 4, 6, it will go on till nth even number, so that is 2n plus 2. Okay, so this is our TR or Tn. Now let's just do one thing. First let us write Tn, so that is 1, 3, 5, 2n minus 1 divided by, we have 2, 4, 6 all the way to 2n plus 2. And let's just multiply it by 2n plus 2 minus 2n plus 1. 2n plus 1 will be the next term over here. So we are multiplying by 2n plus 1. The objective for doing this step, not only in this problem but in all problems, is to basically get a series that will cancel out all the middle terms and only the first and the last term will be left. So we have to check for every sum, like every sum has a different value by which we have to multiply. So for this we have to multiply by this thing. So 2n and 2n will get cancelled, and 2 minus 1 we have as 1. So it's just multiplying by 1. And then we are left with 135 all the way to 2n minus 1, and then into we have, divided by, we have 2 into 4 into 6, and the 2n plus 2 and 2n plus 2 will get cancelled in the first term, and we are left with the previous term will be 2n. Since it is just even numbers, it will be 2n plus 2 minus 2. And then the next term is 135 all the way to 2n plus 1, and then in the denominator we get 246 till 2n plus 2. Okay, so we know how to solve such sums, right? We just replace n by n plus 1 and check. So replacing n by n plus 1 in the first term, we will get exactly the second term. So that just means that all the terms in the middle will get cancelled, and we are just left with the first and the last term. So writing our final answer, not to forget this 2, we have 2 into, the first term will be 1 upon, so it will be 1 upon 2 because n is equal to 1. 2 minus 1 is 1 and 2n is 2, minus last term will be 1 into 3 into 5 till 2n plus 1 and divided by, we have 2 into 4 into 6 all the way till 2n plus 2. Okay, so this is our answer if we are to find the sum up to n terms, and if we have to find up to infinite terms, so this is basically a ratio, and over here it will give a ratio of infinity upon infinity, so that is just 0. So this will become 0, and in that case our answer will be 2 into half, so that is 1.